It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about derivative rule, specifically chain rule. F of x equal to quantity x squared plus 3x minus 2 being raised to the power of 4. This one is an example of a function in which inside that one we still do have another function. So as you can see here, the outer function here, the first thing that we can see is a power function being raised to a power of 4. That's a power function. Inside that one is another function, which is a polynomial function, namely quadratic function. This one is an example of a derivative using a chain rule. Using chain rule would mean that once we have an f of x here and our f of x is in the format of an f of g of x, which means we have another function inside one function. We can get the derivative of that by simply getting the derivative of the outer function times the derivative of the inner function. So let's start with this example. We have f prime of x. That will be equal to the outer function is a power function. So we'll deal with that one as a power, an ordinary power. So let's say here the base here, this one entirely, if you try to picture it out, it represents one variable. So if this is a variable and being raised to a 4, let's say for example, we've got here an a to the power of n. Once you have a to the power of n, getting the derivative of that would somehow lead to an n times a to the power of n minus 1. We are to apply that concept here, in which our a there is the entire x squared plus 3x minus 2. So that becomes our base, and then it is being raised to an n, which is our 4. Getting the derivative of that, we have to put down the 4 beside the base, and then you copy the base, x squared plus 3x minus 2 being raised to a power of 4 minus 1, which is a 3. Then we are going to multiply this one with the derivative of the inner function. We start with x squared, that's a 2x. Next is 3x, that's a positive or plus 3. And the next one, we have a minus 2. Derivative of a 2 is a 0, so we stop until there. Then we do our simplifying. Simplifying this one, which we can just simply consider. By the way, some of the teachers would somehow allow this one as a final answer, but in my case, I would love to see that this 4 here will be multiplied to 2x plus 3, and then this x squared plus 3x minus 2 being raised to a 3 will not anymore be touched. Simplifying that further, we have now 4 times 2x, that's 8x. 4 times 3, that's a 12. We enclose this in a parenthesis because we have another factor, which is x squared plus 3x minus 2 as your entire thing raised to the power of 3. That will be our final answer. Now, what if we have our function being like this? So as you can see, we've got an outer function being raised to a power of 7. We have a power function. And then inside that one, we can see an inner function. But within one term there, we've got another inner function in there. So let's try to have that one using our chain rule. getting the derivative of that function, that's equal to, we start from the outer function. So we have 7 here, we bring it down, and then copy the entire thing. So we have negative 2x to the power of 5 plus 3x to the power of 2 minus 5x plus 4 raised to the power of 7 minus 1, and that is 6. We're not yet done because we need to consider the inner function. We go down to each of the terms here of the inner function. We start with the first term here. Notice the first term is a power. So we need to evaluate that one or interpret that one based on the power. We get the derivative of that. We are to put 2 here beside our negative 2x to the power of 5 plus 3x. And then we have 2 minus 1, which is a 1. Then we go to, we're not yet done here because on this particular term, we still have an inner function. So we try to get the derivative of that. So we have now negative 2x to the power of 5, that's negative 2 times 5, that's negative 10, times x to the power of 5 minus 1, that's a 4. Then we go to 3x, that is with a plus 3. Then we go to the second term, we have a minus 5x, that will be with a minus 5, and then derivative of 4 is a 0. So we stop until there, and then we are going to simplify this. So this is now equal to, for 7 here, I'll just copy that one and I'll copy the rest. I'll have to do something with this one because I believe so I can simplify that one further. So I'm now copying everything. And then from here, we have a single term here, which is this entirely. So that means to say that we can simplify this first before we do the minus 5. So we have 2 times negative 2x to the power of 5. That's negative 4x to the power of 5. And then 2 times 3x. That's a positive 6x. Then we can do the multiplying of negative 10x to the power of 4 plus 3. And then we copy minus 5. Simplifying that one further, we have now equal to a 7 times, let me copy this, okay, this time we are going to distribute this one here to the other binomial. So we have negative 4 times negative 10. That will be positive 40. X to the power of 5 times x to the power of 4. We simply add up their exponents, and that's 9. Next, we are going to distribute this to the outer terms. So we have negative 4 x to the power of 5 times 3, that's negative 12x to the power of 5. And then we have 6x times negative 10x to the power of 4. That's a minus 60 times x to the power of 5. 6x times 3, that will be 18x. And then we have a minus 5. So out from there, simplifying that one, we copy 7 and the rest. And then we try to simplify. So we have here 40 x to the power of n, 9. And then we try to combine this one. This is negative 72 x to the power of 5 plus 18x minus 5. So from there, we can just simply rewrite that one together with your 7. So we have 7 times 40x to the power of 9 minus 72x to the power of 5 plus 18x minus 5. And then we copy the longer one, which is negative 2x to the power of 5 plus 3x squared minus 5x plus 4 raised to the power of 6. Simplifying the first part, we have here 7 times 40x to the power of 9. That will be equal to that will be equal to 280 x to the power of 9. Then we do 7 times negative 72, and that's equal to 504. So we have minus 504 x to the power of 5. Then we do 7 times 18. That's equal to a 126 x. And then we have a minus 35 times negative 2x to the power of 5 plus 3x quantity raised to the power of 2 minus 5x plus 4 raised to the power of 6. And that's our final answer. So once again, this is your teacher Jenny saying, always practice and practice, and that would somehow lead you to a perfection one day.